Hello everyone, today is day 56 of solving a LeetCode problem every day, and today I'm going to be solving first bad version. So, you are a product manager and you are currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check. Since each version is developed based on the previous version, all the versions after a bad version are also bad. Suppose you have n versions and you want to find out the first bad one, which causes all the following ones to be bad. You are given an API is bad version, which returns if the version is bad. Implement a function to find the first bad version. You should minimize the number of calls to the API. So for starters, the most intuitive way to do this would just be through iterating through the entire list. So I can say for I in a range of n, we want to say, so if is bad version of I, in this case we can just return I. So if I run this now, let's see, so case 1 seemed to be fine. Case 2, okay, so the problem is this is actually supposed to start at 1, and this should go to n plus 1. Cool, so if I submit it like this, let's give it a second to finish running. I'm just gonna start talking, but okay, so time limit exceeded. So what the problem is it tells us that we need to limit the amount of API calls that we're making, and we're solving this in linear time right now. So what we're gonna do is figure out a new solution, because linear time is just not fast enough, because we want to minimize the amount of calls we want to make to the API. So what I propose we do is perform a binary search. So if we have a binary search, we're going to have some type of array like this with a bunch of integers in it. And then some of these versions are going to be good, and then some of these versions are going to be bad. The one thing that we know is once the first bad one comes up, the rest of the following spots after that first one, they're all going to be bad. So what we can do is we can perform binary search, and essentially the idea is once our left and right pointer intersect, then we know that we've reached the first bad pointer. So what we're going to do is we're going to start our binary search algorithm. So the first thing we're going to do is we're gonna define our left and right pointers. I'm starting L at 1 and then R at n. And L is 1 because that's just where we start over here. And then while left is less than right, you want to calculate our midpoint. So left plus R minus left, floor division 2. And then if this midpoint is bad, then what we're going to do is set our right pointer to be m. And the reason why we're saying m inclusive is because m is a bad version, so we want to include this. And then else we just want to set left to be m plus 1. So for example, if we look at this array right here, we're going to have something like good, 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 then bad, bad, bad. So our first one is going to be here, and it's not bad. So our left pointer goes here to this B. Now we're looking at this. Now we see that our middle is bad. So what happens is our right becomes our middle. And then eventually we see that this right here, because we see that this right here now is the first one. So if I do this again, let's say we have G, 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 G. Let's do B, 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 B. Now once I look at the middle, I believe it would be this one that we see. We see it's not the bad version, so now this becomes our midpoint. Then we have this right here. This is our midpoint. It is. So this becomes, so we have this right here, and then our right one comes here, and we find out that this is the first one. So the time complexity of this is going to be O of log n, and our space complexity for this is going to be constant. And yeah, that's my solution for the day.